Okay, so let's take a look at cellular automata. We're going to use mireks celebration. This is a free program you can download yourself and play around with it. A nice thing about mireks is it has a lot of preloaded sets of rules and starting positions so that you can see what work that other people have done. So let's take a look at a very simple one. This is just called 12 gliders, and let's just run it to see what happens. What we're looking for with these is complex behavior, emergent behavior. So you saw with this one from a very simple set of rules, which are up here. Just check the rule setup. Again, this is Conway's Game of Life. This is telling us that if a cell has exactly 3 neighbors that are on in this current generation, that the cell will be on the next generation. And this one's telling us if the cell is currently on and has either exactly two or exactly 3 neighbors on, it'll stay on in the next generation. So again, we can zoom in and take a look at the cells. Again, it looks pretty simple, hard to tell from this what it's going to do. And then if we back out and run it, we can run it one generation at a time, multiple generations at a time, or just let it run. So you see it sends out the little gliders. Once the gliders are gone, then it reaches a steady state where nothing changes. So let's take a look at another one. Let's try down here. Again, these are all different CAs that people have done and uploaded. So let's take a look at, say, the Gunstar 3. And back it up a little so we can see it. And run it. So we can see this one is also sending out gliders. Certainly ordered behavior from what didn't look very ordered at the beginning. We can actually use something similar to add. If we come up here to adder, doesn't look much like an adding machine, but if we do run this, it actually sends out our answer in binary. You'll see the stream of gliders coming out. Obviously a 1, this would be a blank and a 1. And we can use this again to add numbers. We can take a look at another type of CA. Let's go down here to rate gun, I guess, and run this. So again, we're getting emergent behavior, behavior which we would have never guessed just looking at the starting position of the CA. The nice thing about mireks too is it gives us a chance to look at other types of CA. Let's take a look at a one-dimensional CA. This is based on Wolfram's work. So let's look at a popular one. This is Pascal's triangle. One-dimensional CAs always start with just one or more cells on in the top row. In a one-dimensional CA, the rows are generations. If we zoom in on this, we can see our 1 dot here. And if we run this, we can see we're getting very ordered behavior. So from a very simple starting spot, as simple as we can get, with 1 cell being on, apply this set of rules, and we get that behavior. What this rule set is telling us is the cell in question is the middle number. So let's say in this case, the middle number, the cell in question is off, its right neighbor is on, its left neighbor is off, so the cell in question will be on in the next generation. And we can just let this run. Certainly ordered behavior. We can take a look at another one. Let's try this one. In this case, there's more dots, but they're all on the first row, again, the first generation. We can let it run. And let it keep running. And certainly that looks ordered to me. So let's try another type of CA. This is the Margolis rules. Most popular one, common one, famous one is this one. So we can let this run. And we see our billiard balls, if you like, bouncing around the table. If we look at the set of rules for this, Margolis rules, we're not looking at each individual cell. We're looking at a block of 4 cells. There's 16 possible combinations of on-off for 4 cells. They're all listed here. And this shows what it's going to look like in the next generation. So let's take a look at what else that we can do. These are called must-see ones. Let's take a look at Brian's brain. Again, it starts very, very simple. Just 2 dots. We'll back out a little. Look at the set of rules. This is a game of life, but in this case, bursts only happen when 2 neighbors are on. So very, very simple set of rules. Very, very simple start. And let this run. And continue running. So this is a very good example of emergent behavior, complex behavior from a very simple starting point, apply a very simple set of rules, get complex behavior. We can also look at, say, something like this. CAs similar to this are actually used in the real world. We can run this. So this is just a simulation basically of sand landing on different shaped objects. But what we can use this for is, let's say there's an earthquake, a building has collapsed, we want to try to find survivors. The survivors are going to be where the air pockets are. A simulation similar to this can show us where the air pockets are. As we can see now, there's the air pocket forming down here. If you like lava lamps and that sort of thing, you can also use CAs for that. Let's take a look at this one. Just what, 5 dots. Set of rules. Looks like Game of Life. Our 2-dimensional CA, at least. Not Game of Life. And see what happens when we run this. Obviously applying color changes, but still fascinating and a great time waster. Okay, so that's a mireks celebration. You should download this, play around with it yourself. It will be very helpful on your second assignment.